Good morning to one and all. Uh, the meeting is going to start in another 4 minutes. Honorable Chancellor of RGUKT AP, Professor K. Chenchureddy, Honorable Chief Guest, Professor C. Balaji, from IIT Madras, respected office bearers of RK Valley campus, and the respected head of the Department of Mechanical Engineering, U. Venkatesh, my dear participants of faculty members, research scholars, industry personnel, and students, a very good morning to you all, and I welcome you all for a 3-day national webinar on thermal management in electronic equipment, which is scheduled from 14th to 16th December 2020 and is organizing by the Department of Mechanical Engineering, IIIT RK Valley, RGUKT. Now let us start the inaugural session by lighting the digital lamp. Now let me introduce the webinar. We all know that when the electronic equipment is in working condition, it generates heat energy. If we want to operate them within operating temperature limits and to improve their reliability, thermal management is required. There are several techniques we are implementing for cooling electronic equipment, like various types of heat sinks, forced air fans, heat pipes, and phase change materials. This webinar aims to discuss the recent advancements in the research and development of thermal management in electronic equipment. From this webinar, the participant will learn the importance of thermal management in various applications of electronic equipment and also the numerical and experimental methods to solve the problems related to thermal management. I am pleased to introduce our Honorable Chancellor of RGUKT, Professor K. Chenchureddy Garu. Professor K. Chenchureddy, a doctorate in economics, taught economics at Andhra University for over 3 decades, acclaimed as a teacher and researcher for excellence by his students and peers, authored many books and papers, occupied several administrative positions like Director, Academic Staff College, and SARC Students Center, Board of Management, Vice Chancellor in charge at Andhra University, Chairman AFSCI for 2 terms, visiting professor at Armstrong Atlantic State University. As an education administrator, introduced many innovative measures in higher education, provided leadership as a founder Vice Chancellor of RGUKT, also served as Chairman Rajiv Yuvakiranalu, a flagship skill development and employment program of United AP government during 2011 to 14 and instrumental in skill upgradation in providing employment to unemployed. Now I request our Honorable Chancellor Professor K. Chenchureddy Garu to address the participants. నిమిషం. ఎక్కడ మినిట్ 1 minute. హరీష్ కుమార్ ఏదైనా
Hello.
Sir, it is audible.
Yeah. Galaxy of invitees to this 3-day webinar on thermal management in electronic equipment. My friends from RGUKT campus at Arcade Valley, Energy Department, Sri Venkatesh, the convener of this webinar, Dr. Kondareddy, the administrative officer, Dr. Mohan Krishna, the dean, Dr. and our own director. She is not available at this point of time. Our distinguished Vice Chancellor. Well, I am personally happy that when we are going forward in terms of technology, and technology invariably involves various gadgets, various instruments, and that's where I think managing thermal systems at the appropriate level of temperature is extremely relevant. I think at this point of time when RGUKT is looking for focusing on research, extension, consultancy, my friends in different departments have been taking trouble to organize webinars, discussions, and workshops. I am personally happy that the mechanical engineering department has taken the lead. I congratulate both the chairperson of the department and leaders of this workshop. IITs and other reputed institutions who would share their views, their contributions, and that's where I think that would certainly motivate our end faculty. RGUKT, we have a strong end faculty team, and we are now trying to nurture them, give them more opportunities to go for research and also for exposure, so that we would come back and they would come back and start programs in the emerging technologies, or what we call disruptive technologies. In this connection, I think universities like RGUKT and on the lines of IITs and other institutions must essentially focus on innovation and thinking in terms of, that's what disruptive technologies talk about. You need to do something in a different way, in an innovative way. The same thing that you have been doing, adopting new technologies and new ways of doing the same technology. Long ago, I think social scientists also have talked about innovation and invention. And now it is in the domain of scientists and engineers talk about these things. And this team certainly, I am sure, will make our faculty enrich. And I once again congratulate our team and wish all the best for the 3-day webinar. Thank you, Dr. Kondareddy, and thank you all. And again, I thank you all our distinguished panelists and then people who will be speaking in the webinar for your time And I do hope that you will have a wonderful, fruitful, and extremely useful discussion for the next 3 days. Thank you very much.
Thank you, sir. Thank you for sharing your valuable points with the participants. Thank you for accepting our invitation and attending for this inaugural session. Thank you, sir.
Yeah, move forward, please. Thank you. It's my privilege.
Now let me introduce the Honorable Chief Guest, Professor C. Balaji. I feel very happy to introduce the Chief Guest of this program, Professor C. Balaji, who is a renowned professor in the field of heat transfer. Professor C. Balaji is currently the T.T. Narendran Chair Professor in the Department of Mechanical Engineering at IIT Madras. He graduated in mechanical engineering from Gindi Engineering College, Chennai in 1990 and obtained his MTech in 1992 in heat transfer and thermal power specialization and PhD in 1995 in heat transfer from IIT Madras in the area of heat transfer. His areas of interest include experimental and numerical heat transfer, optimization in heat transfer, inverse heat transfer, electronic cooling, satellite meteorology, numerical weather prediction and radiance accumulation, climate change. He has more than 200 international journal publications and he has guided 30 students so far for the completion of their PhD. Professor C. Balaji has several awards to his credit and notable among them include Young Faculty Recognition Award of IIT Madras for excellence in teaching and research, A.N. Sitaramu Award and Medal for Excellence in Heat Transfer Research 2008, Swarna Jayanti Fellowship Award of the Government of India, Tamil Nadu Scientist Award in 2010 of Maruti Gurunath Award for Excellence in Teaching and Mid-Career Research Award, both awarded by IIT Madras. He is a Humboldt Fellow and elected Fellow of Indian National Academy of Engineering. Professor C. Balaji has authored 8 books so far. He is currently the editor-in-chief of the International Journal of Thermal Sciences. He is a highly rated faculty member at IIT Madras. I would like to thank for Professor C. Balaji for accepting this invitation in his busy schedule. Now I request Honorable Chief Guest Professor C. Balaji to address the participants.
Thank you, Kunda Reddy. So am I audible?
Yes, sir.
Okay. So good morning to all of you. So it's a nice December morning here, except that we are having some tension here in IIT because you must have seen in the papers that we got back the PhD scholars and 66 of them tested positive for corona. So we're going through some trouble and officially we are under lockdown from today. So, Anyway, so I'm very happy that the university is conducting, your university is conducting this program. Very thankful to Honorable Chancellor Professor Reddy for spending his time and trying to take his time out and inaugurate the program. And this shows the seriousness and commitment of the top administration to this activity. If you look at thermal sciences itself, so originally thermodynamics came when man wanted to pump water. I mean, this may look very strange. Because why did man want to pump water? Because he wanted to get coal, okay, for as a fuel. So why did he want coal as a fuel? Because he previously was using charcoal. He means he or she. They were using charcoal, but charcoal required the burning of wood. And England figured out that if you keep on burning the wood, you cannot make ships. If you can't make ships, you can't expand the East India Company, the British Empire, and so on. So largely due to military application, military goals and objectives in mind, so they wanted to go after the coal. The coal was very deep inside. So to get the coal, they had to remove the water. They tried with horse-drawn pumps and all that. It was not sufficient. So therefore, the steam engine was figured out with Thomas Newcomen, James Watt, and all that. Then they figured out the same steam engine can also be used for mobility. So, so steam engine means immediately we think of steam engine, train, and all that. So The application of mobility came much later. You see, so I think why I'm saying this is you'll have to know the history of technology, history of science to understand fully. Okay. So Auguste Comte said that if you want to understand anything, any science, you have to first understand its history. So what about the history of heat transfer itself? So once we figured out the steam engine and all that, people wanted to convert heat to work. When you convert heat to work, obviously some places heat will be absorbed, heat will be rejected, and so on. So therefore, you wanted to estimate this heat transfer. So originally the goal was always work. That's why thermodynamics first and then fluid mechanics and heat transfer later. So the idea of work is very, very important because work reduces human toil, work reduces human effort. Work makes humans much more productive because just you put a switch and a bulb is on, the air conditioner is working, the fan is working, and so on. So the electricity meant so much to human beings. Electricity was a disruptive technology in civilization, just like the wheel. Okay, so therefore, this idea of converting heat to work came, and this work, the heat transfer in that first law of thermodynamics, Q minus W equal to delta E, or the energy, or for a pure substance that's equal to delta U, where delta U is the change in internal energy. Heat transfer was considered as an inferior cousin. Because once somebody said, okay, once you know what the heat transfer rate, you put it into that equation so that the goal was W, 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 and mostly displacement work, integral PdV. So that some piston can move with that piston, you can make it into work and can put it to a generator, generate mechanical energy, electrical energy, whatever. So work was considered very, very high grade, and heat was considered as low grade. Even to this date, we teach students all the successive generations of students are taught this way. Work is superior, heat transfer is inferior. But without transferring heat, we cannot convert heat to work. That is one problem. Of course, the photovoltaic cell can directly convert it, but that's a different story. Then heat transfer as an independent discipline started developing after the World War II because there are many occasions where the goal is not to convert heat to work. Okay, some equipment is running and it is generating a lot of heat. You want to reduce the temperature. Okay, so this could be an electrical motor that was in the 30s, 40s, 50s, 60s. Now, then came the mainframe computer, the computer, now the personal devices and so on. And now, even if the IC engine is going, if it will go away, if somebody, as many people believe so, the electric vehicle will still generate a lot of heat. Therefore, whenever there is human enterprise, whenever there is civilization, whenever there is technological progress, the generation of heat is inevitable. So this heat has to be dissipated. Eventually, the heat has to be dissipated only in the atmosphere or in the lake or the river or the pond. So the heat has to go to the mother nature. This causes global warming, climate change, and all that. That's a separate. That is a separate thing. All right. So therefore, heat transfer grew as an independent discipline. A lot of development took place in the 40s, 50s, and 60s. Originally developed as an empirical science where people try to develop relations for heat transfer coefficient. Okay, so using experiments. So it started as an empirical subject, then the boundary layer theory came, then Prandtl and his and his students and associates. The Germans did a lot of work. Then along the wrote a lot of work. And so combined conduction convection.
Sir, your voice is breaking, sir. Sir, your voice is breaking, sir. He disconnected. Okay, some technical problem is there. Just give me 2 minutes.
Ideas. Okay, so many people, many resource persons will share their ideas, make the best use of it. Okay, so I will see you later at 3 o'clock in the afternoon. All right. Thank you very much. Namaste.
Thank you, sir. Thank you for sharing your valuable points with the participants and introducing the evolution of a heat transfer to the participants. Thank you, sir, for accepting our invitation and attending for this inaugural session. I am happy to introduce the session one speaker, Dr. N. Gnanasekaran. Dr. N. Gnanasekaran obtained BE Mechanical Engineering from Bharati Dasan University, Tiruchi, and M in the area of inverse bioheat transfer. He has published more than 31 SCI, SCIE, and Scopus journal papers and attended more than 50 conferences. He visited countries like US, Japan, Brazil, UK. He is presently carrying out funded projects for the worth of 4 crores that involves setting up laser diagnostic system for flow measurements and analysis of flow through metal forms. He guided 3 PhD students and 1 MTech research student and presently guiding 5 more PhD students. His areas of interest are inverse heat transfer, bioheat transfer, microchannel heat transfer, flow through metal forms, optimization, and machine learning through MCMC methods. He is a reviewer for reputed journals like International Journal of Heat and Mass Transfer, International Journal of Thermal Sciences, Heat Transfer Engineering, Inverse Problems in Science and Engineering, Journal of Porous Media, etc. Now I request Dr. Gnanasekar